All right. Well, who knows? Maybe we won't get more people, or maybe it's still going on. But David, we can start. Oh, there's Casey. So maybe we'll get more people, but we can get this moving. Um, all right. Let's see.
Alrighty.
Hey, Casey. Good morning. The core stand up is going over, so we might get a couple more people possibly coming in, but they were still in the middle of discussing bugs and stuff, so uh, might be a little bit. But I will get started on PRs here. Um, oh, there's this new RBD cache replicated write log. I think it's part of a previous one that had been uh, submitted maybe earlier, but I think Jason wanted to have this broken up into smaller parts. So this is apparently the first part of the previous one. Um, let's see, there's been Rosen L has been submitting a couple different PRs for NUMA Affinity updates and enhancements. There was one for the OSD, and I think there was another one for RGW. Let's see. This Crimson log level one by Kifu. I don't really know. I'm assuming that's just trying to update their logging not to be as impactful or something. Um, let's see. Eric's adjust allowable bucket index shard counts for dynamic resharding. That one merged apparently. Um, and then Adam's one that fixes some of the write-ahead log behavior. Uh, that was kind of in anticipation of his RockCV sharding PR, or was necessary for that. That merged, so that was good. Um, lots of updated stuff here. I actually have not gotten through all of the old PRs, but I think got through most of the ones that matter. So let's see what has been updated. My PR for pinning O nodes in a separate list for the O node cache in BlueStore was tested, approved, merged, and then we unmerged it. We reverted it because it was breaking a couple of tests that I had missed. It's not clear to me why it's broken though. I asked Josh finally to take a look at it as well, just to make sure, get another set of eyes on it. But I'm a little suspicious that maybe it's we have some broken behavior somewhere else, and this is just exposing it. But one way or another, we need to figure out what's going on before we try merging it again. Let's see. I've got a PR for increasing the default number of RGW bucket shards. Casey, we can discuss this more if later on, but my recommendation, I guess, would just be to let's test it and see what happens. Let's see. We've got Eric's PR that's gotten some updates for reducing bucket listing overhead with multiple shards. There's been lots of discussion on that one regarding how to deal specifically with kind of the case where you you may have very few entries per shard. So say if someone requests a very small page size in terms of how many entries are returned at once, or if you have a large number of shards but very few objects actually in the bucket, then this might be the case, and just kind of how we deal with that. Let's see what else. MDS auto tuning of MDS cache memory limit that needs to be rebased again. The work is still ongoing. Patrick continues to review that. Adam's RockCV sharding PR. I tested that a couple weeks ago. Adam is also doing a bunch of testing on that. And Adam, you're here. So if you, maybe after we get through the PRs, if you want to talk a little bit about what you've been seeing and what you've been testing, that'd be great. Let's see, what else do we have here? Fix broken unused calculations in BlueStore. I don't remember what that is, but I think it's was buggy, so it's being fixed. Igor reviewed that. Oh, and Igor, you're here. So yeah, I don't actually know anything about that one. Is there anything interesting going on there? Or what does it even fix?
Well, actually, the ticket is with the PR is on my plate. It's not passing QA at the moment, and the author passed it to me since he doesn't have enough time, so I'll take a look.
Okay, cool. Let's see. Adam, his iObject PR is continuing to move along. It looked, from what I just looked at it, it looked like it was passing a toothology run, so that's exciting. I think maybe Josh also took a look at that and approved it, in addition to other people also having taken a look. So that's really good. Hopefully that gets merged soon.
My understanding is that there's only one blocker in the Ceph suite, and he's been furiously working on that one.
Fantastic. That's great to hear. All right. Let's see. The IOU ring, IO engine, and Blue Store. So we did have some discussion a while back about that, and maybe like kind of refactoring a bunch of the code that's related to AIO and Blue Store. But that can be a bunch of work, and I don't think anyone has time to do it now. So the gist of it is it looks like it's working. I think Kifu looked at it and thought it was fine, so I also approved it this morning. We'll get it in. There's no real easy way to test it right now because it requires newer kernels than any of our test machines have. But it's not going to hurt anything, I don't think. And at some point, maybe we'll look at cleaning up the different I/O paths to be more independent. But for right now, let's get it in. So hopefully now, assuming that it passes stuff and Kifu's happy with it, we'll merge it. Let's see. Work in progress, OS Blue Store, speed up pool removal. Igor, this is your PR. Anything going on with that?
Yeah, well, the idea behind is that currently when removing pools or placement groups, we have pretty large overhead on collection listing, so we run multiple small tasks which retrieve just 30 records in the loop. So for huge placement groups, it might load the Blue Store significantly. Not to say it's pretty slow. And here is the attempt to introduce a sort of caching or prefetching for such collection listing, just to reduce the overhead it requires. Well, actually, it's ready for review. Sage has another PR based on this one. And also I have additional idea about making collection listing asynchronous, because current implementation might stuck for a while under some circumstances. And actually I've seen how this caused suicide timeouts. So, well, design of collection listing should be improved, in my opinion. Anyway, this part which implements prefetching is ready for review. About asynchronous collection listing, it might need some discussion. That's it.
Cool. And then last one is Adam's objection sustained, and that got I think some updates over the last 2 weeks, but I don't know where that one's at right now. Casey, or no, Adam, you're here now. Anything new with that?
Just bug fixes. There is one more bug fix to go, and then we can merge in.
Awesome. That is exciting. All right. The rest of the stuff has not been updated, so I'm not going to go over it. All right, let's move on then to discussion topics, which I have not added in here yet. But maybe the first thing we could talk about, what I put in the email. Let's see. It was RocksDB sharding. Adam, do you want to talk about some of the stuff you've been doing on it?
Well, not really, but yes.
Okay.
I'm basically the sharding has been done by, of course, using column families of RocksDB, and sharding to a specific shard is done by calculating some hash, and this solution was extensively tested by me for performance. There is a presentation that was given on Ceph Day this week in Wrocław, Poland. The results are as follows. It seems not to give any reduction to latency, tail latency, significant reduction. There are some test cases when this tail latency can be observed, but in general, latency became greater, so worse. From the positive side, we have a much better write amplification and much shorter compaction times, like 2 times, even up to 2 times, and also write amplification up to 2 times better. But beside that, I would rate its performance, it's unsatisfactory, but I just simply refuse to acknowledge that this solution, sharding, would somehow fail for RocksDB if it was so successful in other cases. I will just roll, now we'll be tasked to roll out why we have a higher latency in typical cases. I see this slowdown from perf in RocksDB. So maybe it's just that RocksDB handles column families less efficient than usual columns. I have to confirm that. If so, then second attempt at sharding would be to actually invoke multiple instances of RocksDB. But that would be hugely difficult, as additional sharing of BlueFS or something else would have to be done. So basically, that's it. So from my point of view, only the first of the 3 pull requests is actually useful. The one that makes integration of column families into our KV database and allows us to properly assign, properly share data, not just by single prefix, but have it more complicated. So that's it basically.
That Adam, I think it sounds like the results I saw when I was testing also kind of match what you were seeing. I can link those again. I think you've seen them already, but it was not higher performance, not significantly worse, but maybe a little tiny bit worse, but then much lower compaction overhead and much lower write amplification. So still good, I think. Still worthwhile.
That has to be discussed. I personally would not pay the cost of higher latency in typical cases.
Do we know why it's giving shorter compaction times?
The hypothesis is that by not descending as far down in the hierarchy, by having multiple parallel hierarchies that only have like level 1 and level 2 versus level 3, level 4, whatever, that you are reducing the amount of write amplification.
And
Okay,
there's
so the
also
reason why that worries me is you could get the same effect probably by increasing the number of SST files per level, right? If all you've done is
Yes.
effectively multiply the size of level 0, level 1, etc. by a factor of whatever you are partitioning it by, all you're doing is delaying it by some constant factor of the workload.
The difference there, though, is that you could have multiple level 1, level 0 compactions happening concurrently when you have multiple hierarchies, right?
Okay, that's a fair point. It's also possible the increased latency is a direct consequence of having a much, much wider level 0. If more of your data is in level 0, then looking for data in level 0 is less efficient than looking for it in level 1. So you might
okay.
consider
I
constraining
understand
the
that, yeah.
number of level 0 SST files. You drop that by a factor of if you drop that by a factor of whatever the partitioning is, that might recover the latency.
No, it does not drop by factor of partitioning. It drops by factor like 1.2, 1.3.
No, I mean if you change the config setting to drop the target number before compaction, so that you have the same level 0 files, number of level 0 files, whether or not you have starting turned on, then you might recover the latency if that's the reason. So instead of having 10 trees of the same size, you'd have 10 trees of 1/10 the size each. At each level, that is. Particularly level 0.
Sam, one thing I've been a little worried about with this is that I've seen some opinions, we'll say, on various mailing lists and things that that when you have a large and thus somewhat undefined number of column families, that you can potentially hit some locking issues with the write-ahead log. I'm wondering
I
a little
believe
bit
it.
if
And
that
if that's
could be...
true, that would also make sense, but it would show up in perf, right?
Locking wouldn't, unless I guess you were looking for if you were doing the weird like Futex logging that theoretically you can do in
all right.
perf. But you could use Adam. You could use your walk clock profiler or mine, maybe.
I intend to do that, yeah.
Yeah. Adam, have you tried testing it in a situation where compaction is a major contributor to slowdown, like performance slowdown?
How can I trigger that? By injecting compactions?
There were some scenarios that we saw from customers where they were seeing like 20 or 30-second compactions, and it looked like maybe the write-ahead log was starting to throttle because it couldn't keep up with the compactions were so slow that it was triggering that the write-ahead log was getting into this slowdown state, and then the ingest rate for writes was really low, was lower. And I was curious if your PR may help in that situation.
Well, that what you explained could be an explanation for like sometimes having latency of operations like 13 seconds or even more. So I guess in some tests I do have I might have that, but I did not observe it directly. I mean, I did not have any toolkit set to actually confirm that I'm having that.
Okay. Yeah, if we could kind of craft one of those scenarios where it's really taking a long time to compact under the current master code. I still suspect that your PR may make it much better.
Uh, you really think about, you really care about compaction taking a long time, or you just care for new operations being stalled during compaction?
Probably both, right?
Yeah, because I don't care for how long compaction takes, for as long it does not eat too much space for
Yeah, there's
Oh,
logic in
temporary write
Bluestore.
amplification.
Yeah, there's logic in Bluestore that blocks incoming writes if compaction gets too far behind. I think that's what we care about. So compaction throughput really is the important part.
and in addition to that, Sam, there's logic inside RocksDB itself where it starts throttling writes to the write-ahead log if compaction is if the number of buffers, write buffers, have already kind of filled up, which I think would basically be the same kind of idea.
Right, but in either case, it's not that you care about how long compaction takes, it's that you care that compaction never gets too far behind. So it's compaction rate, really.
Yeah, sure. You could have one giant compaction happening, I guess, that like doesn't matter as much, or you could have tons of little ones, but it's the rate, right? Ultimately, that matters.
But at least I seem to have test cases where I have repeatedly occur very long write operations for like more than 10 seconds. So I will dig out my test cases to extract if this is not the case.
Yeah. And even besides performance, right? I mean, your PR is going to help on drive wear significantly for flash drives.
Yeah.
And that's a big win. Even if there's no performance win, that by itself, if we can make people's flash drives last 4 times longer, that's a big win.
And one more note about why compaction in that case may have a smaller data produced. It's because if you have some pool that has just OMAPs and you add it a lot and there's a trigger for compacting OMAPs, then it doesn't really touch any other objects in any column. So that would also have impact for reducing write amplification.
Yeah. Anything else that we should discuss on RocksDB sharding? All right, let's move on then. The next thing I had in this was Bluestore trim update. I guess I already kind of covered it. Gist of it is that we broke master briefly. I'm trying to figure out why. It doesn't appear that there's anything really obviously wrong with the PR. I am still suspicious that maybe we're exposing some other bug in Bluestore, but Josh will maybe have time to take a look at it, and then we can figure out what's going on. So moving on from that, okay, RGW bucket sharding and shard counts and all this stuff. We don't have Eric, but Casey, you're here. So I've got a PR where I was advocating once we have the bucket list efficiency PR merged, that we up the number of shards. I'm advocating for a very high number. Casey, I think you were advocating for something a little bit more conservative. I guess I would advocate that we just try testing a bunch of different prime numbers of shards and see kind of with all of the work that we've done, and then plus Eric's work, kind of where we end up. Does that seem reasonable?
Well, I mean, What exactly are you testing for? It seems like your benchmarks so far have just been for single bucket throughput, right? There, it's clear that more
Yeah.
shards are going to give higher throughput.
So from what I'm seeing is that the advantage of more shards primarily is going to be with a single bucket or a small number of buckets, because otherwise you get the parallelism anyway with lots of buckets. And the disadvantage primarily is the cost associated with bucket listing, that it makes it slower. So those are kind of the two. To me, it seems like those are the two things: is the offset or the improvement that you get in single bucket write throughput versus the performance penalty of what it does to bucket listing throughput. Does that seem reasonable, or does that seem right?
Generally, yes.
Are there other things to worry about too?
I mean, there's bucket creation and deletion. More objects would take longer, but I mean, that's not too important unless your workload is constantly creating and deleting buckets.
Sure. I suppose too, there is with more shards, you get better deletion performance within the bucket too, right?
In the same way that you get more write throughput, sure.
Yeah. So I guess the trade-offs are, with more shards, listing slows down to some extent, which we probably should retest to see how it is now. Potentially the creation and deletion of buckets themselves is slower. And then the trade-off, the benefit potentially with more shards would be faster single bucket write throughput, faster single bucket object deletion, and that would probably primarily be it. Does that sound right?
Yeah, but I feel like one thing that we're not considering here is how we scale with or adapt to the workload with resharding. And our tunable there is basically the 100,000 keys per shard before we look to split.
Sure.
And and I think I'm very interested in looking at that and figuring out if it's giving us the right scaling. And so when we're talking about picking a good default for new buckets, I think that we just want to fit that into the model for how we adapt and make sure that the curve, I guess, looks right. So that's kind of why I'm hesitant to add a ton of shards, because then it's going to take forever before we start resharding and adapting to the workload. Right? Because if we pick 7 or 8 shards, you can put almost 1 million objects in the bucket before it starts adapting.
And what would be the downside of waiting to adapt until you hit that, like, say, one point, if we were, say, doing like 17 shards, what would be the downside of waiting until 1.7 million objects before you increase the number of shards again?
Well, I feel like buckets that big are probably not common. Either you have a couple really big buckets or you have more smaller buckets.
Would there be like a penalty that we'd impose if people had lots of buckets that all had 17 shards versus lots of buckets that all had like 7 shards?
Not especially. I mean, you just have more objects in Rados and the metadata for that, but doesn't sound extreme.
And when you came back to what you were saying about the number of objects per shard, right now we have it set at 100,000. Do you have a feeling like what would be a better default, or kind of what we should be looking at?
I really don't. We kind of just picked that number on intuition a couple of years ago, I guess, and we never really looked into it scientifically. So I feel like it's probably not right. I don't know if we actually want something that's kind of linear like that. So I do think that this needs a closer look to see kind of when and how we should adapt to growing buckets.
The downside of having like too many would be that you would be pounding a smaller number of OSDs, right? Like if you let like each shard have like 1,000,000 objects or something instead of 100,000 or 200,000 or whatever it is right now. Is that right?
Yeah, that and like large OMAP issues, too many keys on a single OSD definitely impact performance.
I imagine that probably also depends then on kind of how your OSD is configured. I would think that if you had more memory and faster devices in the node, you probably could handle more objects per shard.
I think so, yeah.
So really, maybe it's not even a parameter that can be easily guessed at up front.
Right, and I think that's why it's hard for us to just rely on intuition for this.
Is there anything in the telemetry data that we could look at what's coming in and see if there's any information about objects per bucket and things like that?
Currently, no, I don't think we're collecting anything like that.
That's too bad.
I see Matt joined. We were just talking about resharding and how we scale with more objects, talking about whether the 100,000 keys per shard is sensible, and how that kind of and how that influences our decision of the default number of shards for new buckets.
Okay. Yeah, I mean, I think it was intended. When Yehuda and I came up with that, it was Yehuda's intuition divided by what was safe for a spinning disk divided by 2.
Would it be terrible to look at the latency of operations and try to base it based on like how quickly the OSD is actually like returning stuff?
I don't know, but we're also looking at other strategies to represent bucket indexes. But in terms of this, I mean, that might be correct. I mean, I apologize for missing the first part of this, and I'm not going to blather a lot. But I'd like to talk more with Adam in this context and learn more about whether that's true, whether that's a likely assertion. I mean, if we're seeing a response, I'm saying if we're seeing a behavior that would suggest that would work, or if we have a way of investigating that. It's novel. It might be true. That would help. I don't know.
Well, I guess one question is, so right now how
the loadings behave over time, and how are they interacting together when they're in all that?
Yeah. Right now, I guess the behavior is that we pretty quickly shard out. If you get several million objects, you'll fairly quickly start ramping up the number of shards up to some maximum. What is it, like a 1,000 or something?
Okay, separately, yes. You're on. I think you're on the right on a right track here. We need I do believe we need a different type of growth curve for sharding. It appears like you probably want to jump to sharding quite quickly, but not necessarily very wide, and then grow less frequently, but more. To me.
Yeah. So hey, this is Prasad from Flipkart. On the topic of numbers, we've had clusters which were statically sharded to 32 shards, buckets which were sharded to 32, and had a cap of 1 million objects per bucket, and that has served us quite well. But when we on another cluster which was running Luminous, with dynamic sharding, we had this one, 100,000 objects shard limit. And we were seeing, occasional slow requests coming in, primarily because the total number of objects itself was high. But no matter who does a delete, there used to be a lot of tombstone entries on the RocksDB, and so this 1 lakh itself, seemed not quite helpful. So to me, the 1 million divided by 32, which comes to roughly about 30K objects per shard, seemed like a nice number. So I don't think that the 100,000 that we have is too aggressive or needs to be, increased.
Oh, you don't? Okay. Do you find that you should be observing? I think when you use an even, for example, a non-prime number of shards, which we addressed in upstream just recently, that wasn't the intent of the original designs. It's just a simple to use modular arithmetic, so it shouldn't be doing that. So I think you get a significant imbalance even then.
I don't know if it's a stupid idea, but we were wondering why. I'm probably missing something basic. Pardon me for that. But we were thinking why there was no, per PG RocksDB instance. Why is it that we had to have one big RocksDB for all the PGs on a given OSD, and no matter who does a delete on mapping to whichever PG, it affects, this, the primary OSD.
So when BlueStore was written, Sage would be the one to directly ask, but I think some of the intent was that when you do a write, you would be able to have the entire transaction only hit the write ahead log as a single operation, right, or a single transaction. That you have, instead of spreading out lots of RocksDB instances and lots of logs over a hard disk, with potentially lots of random I/O happening, then you hit one log with all of the things necessary to actually commit that particular operation to disk happening in a single write, and then you'd avoid potentially on hard disks lots of random I/O.
Yeah, so in our case, our index pools are stored on SSDs vis-a-vis, the data pools per se. And so random I/O isn't, much of a issue. And I was referring to the RocksDB instances used by the index pool and not the, the BlueStore themselves itself.
Well, I think you're sailing right into the use case or the research plan of Adam's work. So, as I understand it.
Yes, it is.
Sorry, somebody's.
There is intent to actually make forward with attempt to sharding that we do today. The step 2 might be to actually employ multiple RocksDB instances, but it's much more difficult since we have then to take care of atomicity of operations outside and have some outside mechanism that will allow that what we currently have for free, which is that in one transaction you write new object, allocate data for it, and all that atomicity is provided by RocksDB features. And if we split it, we have to re-implement it outside. So it seems we will.
If we split it on a per PG basis, don't we have that atomicity carried over?
You have that on placement group level, but you don't have that on level of single disk and accessing storage on that level. So on that level, you have to recreate it.
Probably I've not understood the intricacies, but thanks for letting me know that somebody has been thinking about it. It seemed like, yeah, that's how it should have been, because our the primary thing is my RocksDB is just too bloated on a given SSD. I'm talking of an SSD partition of 350 gigabytes, and we just ran over the BlueFS partition. We moved to db.slow, and then still spilled over. And it's just too heavy with a lot of slow requests coming in, and then we had to keep adding more and more OSDs, and then making the size of the RocksDBs much thinner, and the compaction times were like really large on a per OSD basis.
So Prasad, right now, kind of the hacky way to get around this, right, is to actually put multiple OSDs on a single, flash device, which is kind of like, a poor way to do the exactly what you said, right?
Yeah.
So,
the software bloat would just, kind of kill me. I'm already running on a VM on top of a mothership, OS, and what all the multiple layers that are involved in it. Got it.
So that it might be that at least in the short term, maybe it's a combination of Adam's approach and that could get us at least somewhere. And then Adam, maybe potentially we could actually do sharding at the database level. There was something Sage had mentioned when I had talked to him about this a while back, where we can't just shard implement multiple databases per PG. There's something else, I forget what it is, that makes that a little difficult inside the OSD, but I don't remember the details. So it's not as simple as just saying, okay, let's have a hash of PGs that map to different database instances and just kind of like throw stuff at them and then throw a transaction at them and then let that take care of that PG. We have to do a little bit more than just that. So I don't know. We'll see how it goes, I guess. So Casey had to go. Matt, do we know or do we have any idea of, like, I guess we know that before we implemented any kind of bucket sharding, if a particular bucket got too big with too many entries, we started running into like weird OMAP problems, right?
Yeah, it simply was untenable. And the first, and for that reason, that was when indexless buckets were created. I mean, it simply hit a wall, and as you'd expect.
How big was that?
The logarithmic wall. I think maybe I reckon this is on equipment 3 years ago, but maybe 300,000 objects. The number I remember.
Okay. Was that only on file store?
I think it was on file. So of course it was. Yes, of course, certainly file store.
Yeah.
And it was initially on LevelDB, and it would have been objects in the workloads I'm familiar with, maybe between 60K and 100K.
Okay. So really, we don't have a real great idea of how many objects per shard we could maintain now with BlueStore and new.
No, and I think although I would not to Prasant's experience, my intuition though would be that on Flash or NVMe we should be moving up.
the problems before, were there any ways that we could identify in code that we're starting to run into those kinds of problems? Like, would latency be a good metric, or are there other metrics that we could look at that would start
Oh,
telling us
certainly, yeah.
internally
We
that?
didn't write any code to do that, but certainly, I do think that yes, you're on the right track to think that measurement of latency is
Okay.
sensible. We were just doing it
Maybe
informally.
instead of, yeah, maybe instead of asking the user to specify a number of
But-
objects per
Well, I
shard,
but I mean, if Kyle Bader here were here, he might present a counterpoint. I mean, Amazon just added user visible sharding to the AWS scheme. If you now access shards by constructing a bucket with a Unix like / shard name / prefix, and you are ensured that it's or strongly implied that you get a shard affinity by doing this.
Interesting. Why did they have to do that?
Well, they ran into issues. I believe they ran into issues similar to ours, but they wanted why they chose to make it user visible so that users can construct work. They wanted to construct some type of guarantee or partial guarantee that the users would know that they probably were asking why how do we get guaranteed parallelism for a work when they were and that was a way to get it plus make it visible to applications in a way that did matter to customers.
Okay. So the assumption here is that
I'm not saying that we want to do
point.
something like this. We don't. I mean, I think transparent sharding is the way to. I don't think we're going to be permanently using this type of sharding. I think using a simple, using a hash-based selector to place everything is a great way to get uniform distribution, but it has the issues it has. I think we're moving out of that. It may always be a good strategy for some workloads. I don't know which ones, but I think other things we're looking at doing. We have this with the splitting-based approach that but then I figured out at this stage that we probably just want a B+ tree approach. And we've got working out design and implementation for that.
Mm-hmm. Mm-hmm. Yeah, in my ideal world, there would be no splitting for most people. If we could get to the point where we could have a default number of shards that's not significantly impacting any performance at all, and then it's fast enough that for most people they don't care about having more shards.
But when
and
people
also
are beginning
they
to
don't have
say,
enough objects that.
sorry, I mean, people are beginning to say it's a new thing, which is that it's not so much the sharding, it's it's not so much the shard structure, especially after your in Eric's improvements to enumerating things, and it was unexpectedly good. That may short circuit the need for a different way of doing splits, that aren't fully autonomic. But having said that, people can still say, well, it's shards. We see it's shards too. The overhead from sharding is high. So in the ramp up to in a workload where we're ramping up to a natural distribution, as opposed to workloads where it's fluctuating highly a lot. I don't know if the latter is all that common, to be honest. I think there's a common workload we hear about where we're starting creating a new bucket and we're flooding and things are flooding in. We're getting to the natural sharding we think we should be at any rate for the steady state size that the bucket. In other words, it's the peak size it reached in a sustained workload, say, and then we should try to avoid doing the sharding over and over as we bounce through a bunch of intermediate points. It feels like to me.
Yeah. If we can get rid of a lot of the resharding at low object counts, I think that will at least kind of make a lot of the problem kind of go away, right?
And we've now seen that, for example, with your improvements and Eric's improvements, whatever, that's the binning stuff. If you just do this right, the result is much better than certainly that I predicted. Much better. That means that if you start at 8 shards or something, or 7 shards, then things look really things are probably pretty good for a long run to come. If you bounce it a
Yeah.
couple more times to get to multiple millions of objects, and that would be tolerable.
My hope, and I know Casey and Eric have expressed a lot of concern with this, but my hope is that when we actually start testing some of this, we might see that the impact of even more shards on bucket listing isn't very significant. Like we might be able to get up to 17 or even like 31 and have very little impact on.
I think those aren't big numbers, so I don't think that's crazy. So I think we should look at those low.
Okay.
Pick a good number that's and then the small size bigger. Erring on the larger size is better if we don't see a big variance. So I think that notion is correct. But pick our small good number around. If we could pick it higher than 7 or something, if we could pick it at 17 or 31, yeah, I think that's good. My intuition is
that's my hope.
But then don't bounce. Then don't bounce through these constant, right?
Exactly.
Reshards.
Then,
That's pessimal. So we can fix that. We can fix that without studying, without measuring latency and then guessing. We can pick a curve and run it.
I wouldn't be surprised too if we have like a kind of a bimodal distribution of object counts per bucket. Like it's either going to be like under 1 million or like 500 million or something.
Well, yes, that's probably pretty common, and there's some other weird ones, but yeah. But maybe it would be useful to actually measure such distributions. And some of Eric's work on what he called lumpy buckets, he was looking at that, and he collected some upstream information. If other folks have upstream, if people have upstream, possibly either publicly viewable or obfuscatable bucket listings, this could be useful to us. I mean, it would be useful to perhaps track that. To track the structure of bucket distributions and learn from them.
When users have problems, like in the past that you've seen, has it usually been that they try to keep like tons of objects in one bucket, or do they have lots of buckets that they distribute stuff over?
Both. We've seen both, and people have, and applications have infer things about why they would do each one. Sometimes it's just random reasons, and other times I think one's going to be faster than the other, or maybe it is or maybe it isn't. There are also workloads where people construct and destroy buckets of the same name frequently, producing to create transient data sets or recycle or data sets that are like snapshots or being replaced by new by new information. So
presumably one thing
but a common one is just like it's like a FIFO, and it reaches some size and then it's just churning. There's a large entity that pushes news stories.
So Casey did mention that creation of buckets and deletion of buckets rather than deletion of objects in buckets is something that we want to look at here too, which it sounds like maybe what you're just saying is also...
It's needed for some use cases.
Okay.
There are applications that want to do this. Obviously, okay. I can't see why you wouldn't. But you get used to to the idea that an S3 data set is just sitting out there, and a lot of times it is, but there are folks that do that. And we've added the ability to move buckets around, to rename them, that is, and that will probably if people realize they can do that, they will probably do more of it.
Sure. We had a question in the chat window here from Prasad about prime numbers. Matt?
I know nothing about prime numbers in Crush. Maybe Adam or you do, Mark. But the bucket sharding was supposed to be using them, and it wasn't.
Sorry, does it benefit or harm if there are prime number of shards for buckets?
Absolutely, it does, because the intent, we're basically just taking the number of shards modulo the shard count to get to place a name, we're taking some random construction based on the name of the object and modulo the shard count to place it in a shard. So
sorry, it's not clear. So you think a power of 2 number of shards is what is recommended?
Oh no, that's sort of the worst probably.
For buckets.
Okay.
For bucket
Bucket
sharding,
shards.
yeah. This has nothing to do with Crush. This is all well understood in Crush, and Crush experts
Got it.
should be the only ones who speak about Crush.
Yeah, I was thinking that
Yeah,
the default was 32 in Hammer, but yeah, I'd be glad if there's any write-up. I'll look up the code, but if there's any email or any reference, just I'll be very glad to if you can drop a note. I'll take a look.
I apologize for nothing I said I was not speaking about this Crush comment, and I know nothing about
No,
optimizing.
let's leave aside the
Crush
crush,
hierarchies.
but the number of bucket shards.
The Mongo
if
bucket
it's
shard
a prime
should
number.
always have been prime, or and so that the name we the hash we construct of the bucket name is relatively prime to the number of shards. This will automatically
Okay.
happen. This will automatically happen in new versions of Ceph.
Okay. Thanks.
All right. Well, I think we're out of time, guys. So, any last minute things before we wrap up? All right. Well, if I have time this week, which I'm hoping I will, but we'll see how some of this other stuff goes. Matt, I'm going to attempt, I think, to run some tests using Eric's PR and look both at the bucket creation and deletion times along with listing times, and then write throughput and deletion throughput of objects within a bucket with different prime number counts, just to kind of get an idea of where we're at.
Okay, yeah. I like your idea of starting at a slightly bigger number.
Okay.
But not much. I don't think you're going to notice much difference, but I think it's going to behave. It's like you say. It should behave better as we as they scale up. If we could find a better, in general, a better curve, of reshard points, I think that'd be one of the simplest ways to fix it. Would just be have something that an equation that grows better, and it only jumps a few times to get up to the peak.
Yeah. So maybe another dimension of this is also varying the number of objects per shard, and if we get all of that multi-dimensional matrix, then we can see what Casey and Eric think. Because I know that they're still a little bit concerned about going with a large number of shards. So.
Well, yeah, we should go with what the numbers say. I mean, if they observed that it's what did you see? Because I think you tested already. You tested a variety of, right? You looked at charge counts around 8 and around 32 and so forth. Those, if we didn't see, like you say, well, yeah. Let's talk offline. But I don't know what their concern is.
Yeah.
I know what it used to be, but the results we're getting for listing anyway are so good.
That's exactly my thought too. Is that it definitely in master we would not want to go with that many shards, but with Eric's PR, I think it's a lot more attractive. So anyway, yep. We can talk more offline and let this wrap up. But
all right, thank you very much for that.
All right, see you later, guys. Have a good week.